Hey, welcome everybody to our second video of this week. Sorry I'm uploading so late, but it is just what happened. So I'm just going to go through this. It's just going to be one of those kind of easier ones like we were doing before back with Google Classroom. I kind of got the approval to make this part of that lesson. I literally just need you to do what you're doing before. Take the notes. Get those ready to go. I mean, I'd love it if you went the extra mile and did the the extra questions off to the side. Made it more like a full classroom. I'd love it again if you came in some extra tutoring hours to go over some practice problems. But the lesson is literally just going to be watch the video, take the notes, and you'll be good to go. I'm going to keep doing what that one student suggested, where I do the notes kind of more in advance, or at least part of the notes in advance. Then I do the examples in the middle of the video while I'm talking about it. So here we go. I'm going to read this slowly. If you need more time, you can pause the video to write down what I got. But let me tell you what we're doing. This is going to be Graphing Parabolas Part 2. Our essential question says, how do I graph a parabola not in vertex form? So previously we had these parabolas that had that parentheses, the square, we found the h, we found the k, but these guys aren't in vertex form, so how are we going to do that? And the objective, which I wrote up here slightly differently, I can graph parabolas in standard form. That's the standard form. That's actually a reminder word we're going to go over, by finding the axis of symmetry in 5 points. We'll talk about what those 5 points are in just a moment. Now, some students said they don't like me flipping the page over, but the other page has my vocabulary, so I do have to do that. If you have not finished writing all of this stuff down up there, I recommend pausing the video, finish copying it into your notes before I flip this page over here. So I'll give you a chance to pause. Now I'm going to go ahead and flip this page over. So let's flip that guy over. We have only one new word and a reminder word. So the new word is the axis of symmetry, which we are going to shorten to A, lowercase o, s. So AOS, the axis of symmetry. So these words, let's break apart really quick. The word axis is kind of like our axes, our straight lines going left and right. It's like what we twist over sometimes. Symmetry is the same on both sides, or in more than one side. Sometimes you have like 4-way symmetry or 10-way symmetry. Or next year in geometry, you're going to learn about rotational symmetry and all kinds of other fun versions of symmetry. But symmetry just means same on both sides. Axis of symmetry itself for us is going to be a vertical line, which a parabola mirrors on both sides. So we're going to be the same on both sides of this guy. So kind of if I took this over and I flipped it upside down, I would end up with exactly the same picture on both sides. It kind of cuts it directly in half. It is always of the form x equals negative b over 2a. This is our formula for axis symmetry. It's actually going to be what we're using for a lot of what we're doing. What are b and a? Well, let's go back in time a little bit and remember the reminder. Standard form of a parabola. This is a word from way before. F of x equals ax squared plus bx plus c. Standard form of a quadratic equation was another way of writing it. So this negative b over 2a, that's the same as these a's and b's. The c is not relevant to our axis of symmetry. Again, if you are not done copying all that stuff up there, I'll read it one more time. A vertical line which a parabola mirrors on both sides. It is always of this form. Go ahead and pause the video, finish writing that down. And then, I'm going to flip this back over and actually do our examples. So example 1, graph negative x squared plus 8x plus 5. So what we got to do in order to do this, it said part of our objective here is we're going to graph parabolas in standard form by finding the axis of symmetry. Our first step is to find the axis of symmetry. So that's what we're going to do. Our axis of symmetry, as a reminder, we're going to write that formula down. Our axis of symmetry equals x equals negative b over 2a. So that's our formula that we're going to be using. So maybe if we put that in a box just to use for later. We need A, B, and C. We're going to use C later in the a couple lessons, not right now. So let's just write out what A, B, and C are. So A equals B equals C equals. Note how I did that on purpose. I did A under this guy, B under this guy, C under this guy. A is -1. Don't forget there's an invisible guy in front. Please note this A is the same as the A from the other lessons. B and C a little bit different. B is just 8 and C is 5. Those numbers in front for me. So, yeah. So let's go ahead and figure out a couple of these guys. Our first thing to do is x equals -b over 2a. That's our axis of symmetry. So x equals -8 divided by 2 times -1. Remember that we have to simplify. We're going to multiply on the bottom first. So we have -8 divided by -2. -8 divided by -2 is 4. As a reminder, we're going to want to be able to use a calculator. So if you need a calculator, don't forget you are allowed to use that Wolfram Alpha that I showed you. You can use your phone. I'm about to open Wolfram Alpha again because we're actually going to want it for later anyways. So I can show you some cutesy little tricks with it. But for now, this is good. So our axis of symmetry, our AOS, is x equals 4. That is going to be a big deal for this question. I'm going to bubble it so we can graph it later. So the axis of symmetry has a special thing about it. I kind of drew it over off to the side. I'm going to draw one more time what we're finding, what we just found. We found this dotted line that goes through. If you notice, that dotted line goes through the bottom of the parabola. That guy right there is automatically the x value of the vertex. So we can find the y value of the vertex pretty easily. All we have to do is make the x equal to 4, because that's what we found the axis of symmetry to be. So if we just make y equal, and we replace the x with a 4, so that's all I did. I took that x there, and it became the 4 that I just found. Simplify. 4 squared is 16. Please note you're squaring the 4, not -4. So you're going to 4 squared is 16, and the negative of that is -16. Okay. Plus 8 times 4 is 32, plus 5. And if we add that stuff up together, we're going to end up getting, what are we going to get? We're going to get 16 plus 5 is 21. Which means that I now have my vertex. My vertex is the coordinates 4, 21. Easy enough. That is one of the 5 coordinates I wanted. Okay. And now, I'm going to go ahead and say that I have what is called an obvious coordinate. The reason why it's called an obvious coordinate in my mind is this. Is if I make x equal to 0, I'm going to actually show the work the very first time. I will not show the work on the next problem. All I did was taking the equation up here, making x equal to 0. I just get 5, because that's 0, and that's 0, and that's 5. I get 5. I have the coordinate 0, 5. Now, that's going to be the same every time, because actually this coordinate every single time is just going to be, like I said earlier, this is going to be 0, c. That's that c that we wrote up there. Every single time you're going to have a 0, that number every single time on these graphs. That's called our y-intercept. We've actually written that word before. I'm not going to put it as a vocab word because I didn't really want to deal with another vocab word right now, but it's going to be our y-intercept. And you know what? I'm going to go ahead and change our objective up here. I'm just going to say 3 points. I'm going to make our life even easier. We're just going to say 3 points. I don't have to do that much work. And you might say, what in the world? You said 3 points, but you've only found 2. How can I do my graph? Well, we're actually going to graph a little bit first, and I'm going to kind of use my axis of symmetry idea to finish the whole problem. It's going to be a little bit of a small graph because I'm running out of room here, and my next page already has my example written, so I can't even go to the next page. So I'm going to have a small graph, and that's okay. You can have a small graph. It'll be a little bit one-sided graph here too, looks like. Oh well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So this is going to be our x. This is going to be our y. And we need to figure out how we're going to count. Now we have this coordinate 4, 21, so we can probably just count by 1s over here. That's probably fine. But the y's, we probably want to count by something else. How about we count by 5s? So we'll make this, 5. We'll count this as 1, 2, 3, 4, 5. But going up, we're going to go 5, 10, 15, 20, 25. So 4, 21 would be like right here. And now I'm going to draw in the axis of symmetry. I'm drawing in this x equals 4. I'm going to do this in pink. I'm going to go ahead and write x equals 4 one more time. It is a vertical line that is going to go smack dab down this x equals 4. So all I did was I put that vertex down, I put x equals 4 all the way up and down. Now I'm going to graph that 0, 5 over here. There's my 0, 5 that I did. Remember, I'm counting by 5, 10, 15, 20. That's where I got 0, 5. And now, I told you that the next coordinate will be really, really easy to figure out. The reason why is symmetry. This guy right here, I have 1, 2, 3, 4 hops over to the left. So if I instead have the same y value of 5, I can go 1, 2, 3, 4 hops over and get exactly the same coordinate, because it's going to be the same on both sides of this line. And now all we have to do is make it nice and curvy, and we're all done. So in a lot of ways, it's even easier than that previous lesson that we had done. We just had to do a little bit more figuring out from before. So I'm going to go back over one more time all that stuff that we did so we can try out the next one a little bit more on our own. So first of all, we had this guy we were told to graph. It is not in that special form of the vertex form where it gave you that vertex in the H and the K. This time it's in standard form with an A, a B, and a C. So we wrote down what A, B, and C were right away. After we did A, B, and C, we found the axis of symmetry. Our axis of symmetry is this guy, x equals negative b divided by 2a. So we wrote down negative b, that's this guy, there's 8 right there, there's my negative b over 2a, there's negative 1. And maybe I use a calculator or I figured it out, but negative 8 divided by negative 2 is positive 4. And that is my axis of symmetries, x equals 4. That'll be my first step every single time to finding these equations. Next, I took that 4 and I plugged it in to find the y value. So I found that y value, I plugged in 4, I did a little bit of algebra, and we got y equals 21, which means I have a vertex of 4, 21. Afterwards, I found another coordinate. I found the super easy coordinate. Every single time if I plug in 0, the first two guys are going to be 0 here, and then I have this 5 over here on the side. So I got 0, 5. After that, I simply started graphing. I graphed my vertex, and I graphed the 0, 5. After I graphed that 0, 5, I used the concept of symmetry by drawing my axis of symmetry down the middle, and I counted over. It was 1, 2, 3, 4 away here. It must be 1, 2, 3, 4 away here. Now, I didn't actually write that, but if I counted, well, there's 5, 6, 7, 8. There's 8. This one will also have the coordinate 8, 5. If you wanted to, you could verify and plug in 8 back into this original equation up here, and you'll get 5 as well there. that's it for this example 1. We're going to do one more example just so you have it. Please note, if you understood this is actually enough. This is the whole idea of the lesson. But maybe you want to try this next one on your own. So here we go. Example number 2. Graph g of x equals 2x squared minus 16x minus 3. So all we have to do here is start the same way. We need to figure out what a is. A equals 2. B equals negative 16. C equals negative 3. Now I want to remind you guys, if you want to try this on your own, this is your opportunity. You know, I'm not doing a full, more whiteboard problems next or anything like that. It's just, I want to keep these lessons a little bit shorter, but if you want to make sure you're understanding, this is your chance to try it on your own, follow the same exact steps as that last question. So here we go. We're finding our axis symmetry first. We're going to write down x equals negative b over 2a. And we get, did I make it 4 again? Huh. Well, I guess I did, because negative 16 is 16 divided by 4. You get 40. It's not going to be 4 every time, but it's 4 again in this problem. So it goes. Afterwards, we plug 4 back into the equation to figure out where our vertex is. So we're going to do g of 4 equals 2 times 4 squared, 16 times 4 minus 3. Gotta remember our PEMDAS rules, parentheses, exponents, multiplication, division, addition, subtraction. So 4 squared is 16, 2 multiplied by 16, minus 16 times 4 is 64, minus 3. 2 times 16 is 32, minus 64, minus 3. 32 minus 64 minus 3, that's negative 32 minus 3. Remember, I'm doing left to right, which is negative 35. So that means I have the coordinates 4, negative 35. And again, you may use your buddy Wolfram Alpha to do a lot of this stuff, or your Desmos to do a lot of this stuff. So, just FYI, let's actually do that. I said I was going to go back to Desmos, so I never did. I'm not going to turn the page. I'll leave this right here for those still working on it right now. But we're going to go to Desmos, and we're going to show how great this this calculator is here. So let's do it. Let's go ahead. Let's turn this guy up. Oh. All right, my beautiful face is going to disappear for a second. Goodbye, face. Okay. So now we are going to go ahead and graph this guy. So if we typed in g of x equals 2x squared minus 16x minus 3. Now if you graph this here, now zoom out a little bit. I'm just using my scroll to zoom out here. There's probably other ways. I'm scrolling down. Oh my gosh. Oh, there we are. We can actually click down here and it will tell us that the bottom there is 4, negative 35, just like we found. We could have also just plugged in 4, because if you type in right here, g of 4, it'll use what you just used earlier, and it will tell you in that left-hand corner up there that you have negative 35 as what g of 4 is. So a lot of these different ways are nice here. I don't know if it'll graph it anywhere. No, I'll just calculate it. Anyways, I just want to give you guys this option so you guys kind of know what the graph's supposed to look like. It's going to look like this. But yeah. All right, let's get rid of this. Oh, you never saw any of that because I never hit transition. Well, I just talked to myself for a little bit there. Good. Hopefully that was terrible, and we're gonna go ahead and actually hit the transition this time. We're gonna open that guy back up, and then we're gonna actually hit the transition button. Oh boy. I'm sorry, guys. We're gonna do this again. G of x equals 2x squared minus 16x minus 3. Okay, so that's what I did. Is I graphed this on Desmos, then I scroll down all the way here, and I just click that guy at the bottom. Great. Hey, she's laughing at me. I saw her face. I knew I was waiting for it. Man, this is what happens. This is what happens. I deserve it. It was terrible. All right, 4, negative 35 here at the bottom. It shows up nice and neat. Anyways, g of 4 there. If you type it in just like this, negative 35 shows up. I just wanted to show you guys that this is a cool little guy that will do the work for you. So if you want to, this is not cheating. You can use this bad boy. It is cool. Anyways, are we leaving this page? We are transitioning away from me, from this. We are back to me. All right, let's finish this problem. Let's be done with it. Let's actually make it look like that picture we just saw. 4, negative 35 is that coordinate. The next coordinate is always super easy. It is always 0, comma, whatever this end is, that negative 3. 0, comma, C. Okay. Let's go ahead and do the graph. This one can actually be a decent size. You guys can't even see what I'm doing again. Here we go. All right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 6. Yeah, X. And we got G of X this time, not Y. All right. So putting our two graphs down again, I'm going to make these count by 1, 2, 3, 4, 5, and I make these count by 5, so that's up to 25. We got 4, negative 35, so that's 4 and then negative 35, so we got 5, 10, 15, 20, 25, 30, 35 right here. And again, we got that axis symmetry, that dotted line we're going to draw right down the center. We're also going to graph that coordinate 0, negative 3, which is going to be about right there. Again, we are counting by 5s over there. And same thing as last time, we just count over. And because it was 4, it's going to be 4 again. We're just going to count over 1, 2, 3, 4, and then 1, 2, 3, 4. That's why I went out to 8, by the way. Which gives us that coordinate 8, negative 3. And then we just make it nice and curvy up there. It looks just like that one that we saw on Desmos. Easy enough. Hopefully video was informative. For those of you who want to get a little bit ahead, I'm going to explain the first smaller assignment for next week right now, just so you have it. I don't want to overwhelm you, but the first assignment for next week of the two things is going to be this homework assignment right here. And I've divided it into 2 parts. And I'm going to explain those 2 parts a little bit more in depth, but those are the 4 problems. If you don't want to do them right now, you do not have to. Notice it says week 3. We are not in week 3 yet. You can wait till next week. But I do have these in advance. So this is our first homework for week 3. Have a good one, guys. Enjoy the rest of your day and hopefully a great rest of your week.